All right. When it comes to the Pythagorean theorem, we've already gone through and done this. A squared plus b squared is equal to c squared stuff. So now we're going to use it and apply it a little. One of the things that we've got is what's called the Pythagorean triple. These were actually things that a lot of ancient mathematicians tried to find to see if they were going to come up with more of them. And what they mean by a Pythagorean triple are numbers that are integers, not decimal numbers or anything else. So like 3, 4, 5, that is a nice Pythagorean triple. 5, 12, and 13 is another one. Okay. Now there's another one there that says 6, 8, and 10. Well, that's just doubling 3, 4, 5. But they would go through and they would try and figure out ways of identifying different sets of three numbers for a Pythagorean triple. So let's go through and do this. We want to find the unknown length of a triangle, and then do the side lengths actually form a Pythagorean triple. Now remember that it is a squared plus b squared is equal to c squared. And when we're dealing with this, the legs that make up the 90-degree angles, where the 90 is the included angle, A and B. It doesn't matter which one is A, it doesn't matter which one is B. C always has to be the hypotenuse along the one. So, if we're going to go through and do this, I'm going to take A down here is 15, so that's going to be 15 squared plus B, which is 20 squared, is going to be equal to C squared. Now again, you need to be writing out all of this work so that you have it, so that if you do make a mistake, you can go back and double check it. All right. So now, 15 squared. You got that? 25. 20 squared is 400. So that's going to end up giving me 625 is equal to c squared. So really what I want to do is I want to take a look at the square root of 625. So second, got the square root, 625, enter. And it turns out to be 25. So I've got a Pythagorean triple here that is going to be 15, 20, and 25. Okay. Now I want you to pay attention to something. 15 is a multiple of 3, correct? 20 is a multiple of 4. 25 is a multiple of 5. 3 times 5, 4 times 5, 5 times 5. So that original Pythagorean triple of 3, 4, and 5 shows up in here again. Okay? It's a multiple. Now, try this. I want to find out what one of the legs are. It doesn't matter, we use the exact same thing. We can set this up as A, set this one up as B, and set this up as C. It really doesn't matter how you do it again, but I generally put A as the base, D is the height, and C is the other one. So that means I have A squared plus 24 squared is going to be equal to 26 squared. And again, you got the calculator there, but to write all of this stuff up is only going to help you in the future. It gets you accustomed to writing things out and showing all your work. That way when you're dealing with algebraic expressions in Algebra 2 and other things that we do, you get accustomed to it. So, I've got A squared. Yes, sir? No, that's incorrect. And because you got to remember, the hypotenuse is the long side. And the two shorter ones always add up to the longer one. So if you got to keep it in mind like that, that's fine. Keep it, the two smaller ones have to get added together to get the big one. Okay, does that make sense? Okay. So, squared, we end up with 576. 6 squared, 676. So then we just do the algebra. 576. Subtract 576. I end up with a squared is going to be equal to 100. A is equal to 10. So there we go. Do we got another Pythagorean triple? Yes, we do. And that's going to be 10, 24, 26. Okay. So there we go. Again, in Pythagorean theorem, you've used it before. It's not all that difficult to deal with. Now, where things start getting a little on the trickier side is when you don't have things coming out to be nice whole numbers. So, work through this one. I've got A, I've got B, and I've got C. So I've got 12 squared plus 6 squared is going to be equal to x squared. 12 squared is 144. 6 squared is 36. And this is equal to x squared. So 144 and 36, I add those together and I end up with 180 is equal to x squared. Correct? Now, if I try and take the square root of 180, I end up with this weird looking decimal. We do not want this to happen. We want things exact values. Later on, when you're dealing with trigonometry, we need to have things in exact values. So we cannot have this decimal. This is unacceptable. So what we do is we need to give us in a simplified radical form. So that means we have to simplify out the square root of 180. Okay? So what we've got is we have 180. There are a couple of different ways of doing this. And one isn't necessarily easier than the other, but they each have their merits. First thing what we're going to do is we're going to go through and identify all the factors of 180. So I got 8 or 1 in 180. 2 goes into it and I get what? 90. 3 goes into it and I get 60. 4 goes into it and I get what? It should be 45, right? Does 6 go into it? Yes, 6 goes into it 30 times. Does 7 go into it? Sometimes with 7 you just got to simply go through and check. That doesn't go. Ooh, did I miss a number? Yes, I did. 5. 5 goes into 180 how many times? This is where a calculator comes in handy. You can just take 180 divided by 5 and I end up with 36. Okay. Let's see, I'm going to keep on going here. Actually, 5 and 6 should have switched around. 180, divide that by 7. Do I get anything? And the answer is no. Is this divisible by 8? No. How do I know? If I look over here at 4 and 45, I know 4 goes into it, but in order for it to go into it before 8, I would need another 2. I don't have another factor of 2. See, like 3 and 60? 3 times 2 is 6. Is there a factor of 2 and 60? 30. So we know 7 doesn't go into it. We know 8 doesn't go into it. Does 9 go into it? Oh, yes, 9 goes into it, and I end up with 20. Okay, does 10 go into it? Yep, but I get 18. Does 11 go into it? Probably not. Does 12? Yes, 12 will, because 12 doubles 6. That goes to 15, so I end up with 12 and 15. 12 and 15 go into it. 13 probably doesn't go into it. 7 never went into it. So 14 doesn't go into it. So, why in the world would I want to go through and do this? Well, I'm going to switch this around here real quick so it makes more sense when I talk about it like this. If you know what the perfect squares are, you guys know what perfect squares are, don't you? 2 squared is 4. 4 is a perfect square. What's the next perfect square after 4? How do you number perfect squares? Perfect squares are as follows. And I highly recommend that you write these down so that you've got access to them. Number squared. 1 is 1. 2 is 4. 3 is 9. 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100, 11, 121, 12, 144. Our perfect squares are sitting right here. These are the numbers that we want to take a look at. I'm going to give you a few moments here so that you make sure that you have this copied down into your room. Now the idea with these perfect squares are, if I can find a factor of the number that's a perfect square, I can take that square root out. When we're going through and doing this, we always want to look for the perfect square. So if I go through this list, I see that I have a perfect square here at 4. I have a perfect square here at 9. I go through, come back up. I have a perfect square here at 36. Okay? Now, if you are following the procedure, this is where understanding and being able to follow a procedure are, not just guess and check. If I start with the lowest number, which is 1, and I work my way up, when I run across a perfect square on the large side, on the way down, I can stop, because this one here would be the largest perfect square. If I don't run across one, I got a perfect square here at 4, I don't want to stop there. I want to keep on going. Let's say, for example, I missed that and I didn't get the 36 and I went down to the 9. And I went through the list and my biggest one was 9. Then I would factor out the 9. So, this is what it looks like, and make sure that you have this written down. So we end up with square root of 180 is equal to x. 180 is the same as 36 times 5. Square root 36, square root of 5, 6, square root 5 is what this is equal to. Okay? This is the process that you are going to have to go down. Now, mind you, there are some steps that you can probably get rid of. I mean, you might not have to rewrite it like this, but that's only if you see what it is that you need to do. 80, we know, is 36 times 5. Love the perfect square. This is the process that we have to go through here. So, let's try another one. I want to find the value of x. Give your answer in simplified radical form. Okay, so that means that I've got an a, b, and a c. So x squared plus 5 squared is equal to 10 squared. And again, just like I've talked about in the past, write out the equation the way it is supposed to be. Do not go through and do the math in your head and write it down. You are not at the point in your lives yet when you can get by doing that accurately 100% of the time. Subtract 25, subtract 25. So, x squared is going to be equal to 75. So I need x to be equal to the square root of 75. Now, does 75 have any perfect squares as factors? Well, we've got 75, which is 1 and 75 2 doesn't go into it. 3 and 25. Boom. Is 25 a perfect square? Can I stop? Will there be a larger perfect square than 25? No. So I know that x is going to be equal to the square root of 25 times 3. So I could say that the x is equal to what's the square root of 25, by the way? So this would be 5 square root 3. That's the least amount of work that you would need to do in order to solve this problem. This is what you need to have on your paper. Coming up and writing the answer x is equal to 5 square root 3 doesn't cut it. I don't care what the answer is. I care about if you know how to find the answer. Not in the back of the book or on somebody else's sheet or on a calculator. So, let's take a look at example 4. Now, if you pay attention to when it talks about screen sizes on a computer or TV screen size, they always talk about aspect ratio. Now, the aspect ratio is the length and the width. So if I'm looking at a TV, and they say it's 4:3, that means that this is going to be 4x, this is going to be 3x. And the reason that they do it that way is because they can go and create the image, like when you're doing it on a computer, you want to go and create an image at a certain size. You set the aspect ratio, and then as it gets bigger or smaller, it doesn't change in what it looks like. You've seen pictures that when you change them, they get skinny or they get tall or something really goes weird with them. That's because the aspect ratio has changed. Now, for the TV, they are always measured, when they say a 42-inch TV, they're talking about the diagonal width. They're talking about how far it goes across this way. So, if I'm looking at a 42-inch TV, that means this is 42. That means I've got this here. Find the length that refers to this distance so that I get that 42. Okay? Pythagorean theorem. We end up with A, B, and C. So that means that I have 4x. The whole thing is squared. Plus 3x. The whole thing is squared. Has to be equal to 42 squared. Now, this is going to require a little bit of math and algebra going with it. 4x squared is going to be 16x squared. This, 9x squared, is equal to, I don't know what 42 squared is, so that means that we are going to have 42 squared, and we end up with 1764. These two get added together, so that is going to be 25. X squared is equal to 1764. Now, I can already tell that I'm going to have mathematical problems here because this thing isn't divisible by 25, is it? But remember, if you've actually read through the instructions, it says find the aspect ratio to the nearest tenth of an inch. So this means that I get to use decimals, right? For those of you that are still awake. So, divide both sides by 25, divide by 25. So I got x squared is equal to 2, so we take that divided by 25. And now I can just take the square root of that, correct? So, second square root of 70.56, and I end up with 8.4. Oh, gee, that was nice. Came out to be some nice, easy numbers. So, x is equal to 8.4. Now, did I answer the question? And the answer is no. I'm supposed to find the height and the width. So if I take 8.4, multiply it by 3, I know that this is going to be, the height is going to be equal to 25.2. What is the width going to be equal to? That's 4 times 8.4. And we end up with 33.6. So that is what the height and the width of a TV screen for a 42-inch TV are going to be. But again, you can't do this stuff in your head. You have to learn to draw out the pictures and write it out. So, what I'm going to do here is I'm going to put this one up here, and I'm going to give you a minute or so to go through and solve this. All right. Here we go with this one. Now, again, we need to make sure that we are following this a squared plus b squared is equal to c squared. And if you don't have that written down when you start with, or unsure what goes where, write it out. There's no rules that say that you can't do that. We know that this could be A, this could be B, and that could be C. Write it out. Show it. Help remind yourself. So that means that I've got 40 squared plus b squared is equal to 41 squared. So that means that I've got 400 plus b squared is equal to, and I think that 21 squared was 441. Subtract 400, subtract 400, and I get b squared is equal to 41. Okay. Now, is 41 a perfect square? Yes. Oh, I had 40 squared. The other number was 20. Yep. Brain just isn't taking it today. That was 21 and 41. See what happens when you get numbers in your head? You get 20s and 21s and 41s, and now you get, it just works. 40 squared, well, that's 1,600. And 41 squared turns out to be 1681. Well, that looks a lot better. See, now the thing is, if I wouldn't have been writing this down, would you have been able to catch my error, Mr. Medrock? If I hadn't written anything down and I just had a number sitting down there, and I answered the question as no? Okay, but if I didn't write anything down and I didn't bother showing you any work, and all I said was no, yeah, you don't have no idea what in blazes I was thinking. Okay? That's the point. I mean, yeah, some people might take a look at it, but you wouldn't be able to tell me what my error was if all I have written down was no. Or if I might have said that B was a square root of some number, I wouldn't necessarily know what it was that was going on. So, this turns out to be 81. B turns out to be equal to 9. So do I have a Pythagorean triple? The answer is yes. But again, if all you're doing is hitting buttons on a calculator, you're never going to know that. So, give this a try. All right. Again, as I've said in the past, if you are unsure of what goes where, make sure that you identify which one is A, which one is B, and which one is C. So you end up with 6 squared plus 14 squared is equal to S squared. You mix things up when you put them down, Mr. Johnson. So 36 plus 14 squared. Okay, calculator, 14 squared. And I end up with 169, or 196, is equal to S squared. Add 36, and I end up with 232 is equal to S squared. So now I got to figure out what the square root of 232 is for S. So we got 232, which is 1 and 232. 2 goes into it, obviously, right? 232 divided by 2, and I end up with 1, 1, 6. Does 3 go into it? You know how to quick and easily tell if 3 goes into it? Add the digits up, and if that's divisible by 3, then it's divisible by 3. So 2 plus 3 plus 2 is 7. 7 is not divisible by 3. This number is not divisible by 7. Is it divisible by 4? Yes, because it's divisible by 2, and that's still even. We can have 4 in there. So 232 divided by 4 is 58. So is this divisible by 5? Is it divisible by 6? No, because it wasn't divisible by 3. Is it divisible by 7? No idea. 232 divided by 7. And I end up with something that looks like that. So, nope. Is it divisible by 8? Yep. Because I've got this going on here, and that's even in 4, so I know 8 goes into it. So 232 divided by 8. And I end up with 29. So let's see. Not divisible by 9, not divisible by 10. Could it be divisible by 11? 232 divided by 11. Nope. Is it divisible by 12? No, because it wasn't divisible by 3. 13? Could be. 232 divided by 13. Gotta check. And I end up with 17. So 13 is not. Is 14? No, because it wasn't divisible by 7. Is 15? Nope. Is 16? No, because I got an 8 and an odd number here, so it doesn't go up to that. Let's see, 16. What about 17? 232 divided by 17, and I end up with 13. Okay. I've kind of gone over the hump here. I found the numbers 13 to 17, 17 to 13. So, what this turns out to be, 4 is the perfect square on here, correct? So this turns out to be 2 square root of 58 is equal to x. And there you go.